Hey Algebra 1, today we're going to talk about dimensional analysis. And this is a skill that's going to go back and forth across the hall from science to math. And you'll use it as you continue to go up in your science classes and also in some of your other math classes. Dimensional analysis is converting from one unit to another. So converting, changing from one unit to another, such as feet to inches or hours to minutes. And here is our big idea for this particular section. We will use a unit multiplier in order to make conversions. And a unit multiplier is always equal to, well, what do you think? If it's a unit multiplier, then it must always be equal to 1. And when we multiply by 1, which is the multiplicative identity, we don't change the value. We do it all the time when we're renaming fractions. So here's a quick example of when you have used a unit multiplier before. So if we have 1/2 plus 3/4, we use unit multipliers in order to get a common denominator. So if we have 1/2 and 3/4, 2 and 4 are our denominators, our common denominator would be 4. So we use a unit multiplier of 2/2, which is equal to 1, to rename 1/2 as 2/4, which allows us to then add 2/4 plus 3/4 and get 5/4. So another word for converting, I guess, could be renaming. We can rename feet as inches. We can rename hours as minutes. And we do that using a unit multiplier, and a unit multiplier is equal to 1. Now, here you go. Big calculators will be helpful here. Some of our numbers are going to be decimals, they're going to be large, some are going to be small. So a calculator will be very helpful for this section. So maybe you want to pause and go get one. First, let's make a plan, because that's going to be key in working through these problems, is choosing a good unit multiplier. So first, we're going to consider what unit we want to cancel. So if we're going from feet to inches, we want to cancel feet. If we're going from hours to minutes, we want to cancel hours. Second, the new unit, the one that you want, is going to go on the top of your unit multiplier. Third, the canceling unit, the one you don't want, will go on the bottom in order to cancel. So this is our plan. First, consider what you want to cancel. Second, the new unit goes on the top. Third, the canceling unit goes on the bottom. So let's take a look at two that I've got set up for us. This is 330 minutes, and we want to change this into a certain number of hours. And we're going to do this in a very organized, systematic way using multiplication and always writing our units. So if we're going to start with 330 minutes over 1, minutes are what we want to cancel, hours are what we want to keep. So remember our plan. What do we want to cancel? Minutes. What do we want to go to? Hours. So the new unit that you want is going to go on the top. I want hours. So if I need hours on the top and minutes on the bottom, and I need this particular unit multiplier, also known as a conversion factor, this unit multiplier has to be equal to 1. So what do I know about hours and minutes? I know that 1 hour is equal to 60 minutes. 1 hour divided by 60 minutes, that's a unit multiplier equal to 1. So now that my minutes are on the top and minutes are on the bottom, they're going to cancel. And I am going to be left with 330 hours divided by 60. So this is where I'm going to go to my, not my phone, but my handy calculator. Here we go. So 330 divided by 60 gives us 5.5 hours. So 5.5 hours. We just changed from minutes to hours. 5.5 using a unit multiplier. Let's go next. 15.75 kilograms equals how many grams? So we're going to use our unit multiplier, and if you need to look up the metric scale and find out how many kilograms, or the other way around, how many grams are in a kilogram, you can do that. I would suggest keeping a note card with some handy conversion factors on it. I actually know that there are 1,000 grams in a kilogram, so I'm going to use that now. So remember our plan. Let's take a look at it one more time. First, consider what you want to cancel. I want to cancel kilograms. Second, the new unit, the one that we want, is going to go on the top. I want grams. It's going on the top. Third, the canceling unit that we do not want anymore will go on the bottom. So 15.75 kilograms over 1. This is given. Write it just as it is. Times. Here comes my unit multiplier. I want kilograms to cancel. I want grams on the top. So what do we know? We know that 1 kilogram is equal to 1,000 grams. So now, here's my unit multiplier. This fraction is equivalent to 1. And when I multiply by 1, I do not change the value of the answer. So kilograms cancel because 1's on the top and 1's on the bottom. What am I left with? I'm left with 15.75 times 1,000. 1, 2, 3 zeros, 1, 2, 3. 15750 grams is the answer. We're multiplying by a power of 10. When we multiply by a power of 10, all we have to do is shift the decimal, however many zeros there are. So 15,750 grams is the answer. Next, 6.7 miles all the way to inches. Now, let's think about what we do know, and I'm going to bring back my handy-dandy note card here. My first conversion factor is one that you should know. It's one that we have used many times before in school and will continue. 1 mile is equal to 5,280 feet. Now, I don't have one for miles to inches, so this time, instead of using just one conversion factor, we're going to use 2. They're both going to be equivalent to 1. It's going to work the same way. So let's get this set up. So our plan, remember, what we want goes on the top. What we do not want, what we want to cancel, goes on the bottom. So let's make miles cancel. But first, let's just go to feet. So there are 5,280 feet in 1 mile. Miles cancel. Now we've got feet, but I don't want feet yet. I want feet to cancel because I'm still trying to get to inches. So I'm going to use a second conversion factor. Following my plan, I want feet to cancel. I want inches on the top. Hopefully everyone knows that 1 foot is equal to 12 inches. Now before we do any calculations, first let's cancel those feet because now all we've got left is what we want, which is inches. Think about what your answer should be. If we're going from miles to inches, should our number, our answer, be getting larger or smaller? We're going from miles to inches. Miles is a larger unit than inches. When we go from a larger unit to a smaller number, our answer better get bigger. And our answer is about to get bigger. Bring in the calculator because this is going to be a larger number. 6.75 times 5,280 times 12. That gives us 427,680. 427,680. 427,680 inches. And that makes sense because miles are much, much, much bigger than inches. So 427,680 inches is our answer. Last problem for this video. We're going from 1,815 feet and we're going to go to meters. Now this is an interesting conversion because this is going from a standard unit to a metric unit. I'm going to go back to my conversion factors here, which you can easily find just by Googling standard to metric or metric to standard. You can easily find conversion factors online. If I want to go from feet to meters, here's my conversion factor right here. 1 meter is equal to 3.281 feet. I'm going to be able to do this particular conversion in one shot, meters to feet. So what are we given? 1,815 feet. I want feet to cancel, so feet goes on the bottom. What do I want to keep? Meters. Meters goes on the top. So my conversion factor, 1 meter equals 3.281 feet. 1 meter is the same as 3.281 feet. I'm set up now for my feet to cancel. I am left only with meters, which is what I want. And let's anticipate what our answer should be. If we're going from feet to meters, a meter is larger than a foot. We can see it right here. So instead of our answer getting bigger, our answer is about to get smaller than what was given. So let's check it out. I'm going to the calculator here because we're about to have to divide 1,815 meters over 3.281. This is our division. Remember, a fraction bar is a division calculation. 1,815 divided by 3.281 gives us an answer of 553.185, and I'll round to that third place because I'm starting here with 3 places behind the decimal. That's a very precise answer. So 553.185, and yes, that number is smaller than what we started with, so it makes sense. So those are some simple examples of dimensional analysis. We'll do some more difficult ones in the next video.